Two quantities which are commonly misunderstood are mass and weight. A solid understanding of many basic physical principles cannot be achieved without a firm grasp on these two very different quantities. The property of matter, which we call mass, makes its impact on the physical world in two very different ways. The first is in the way mass affects a body's motion. When a constant force is applied to a cart of a given mass, the cart responds by accelerating at a constant rate. The magnitude of the acceleration is given by the acceleration vector. If the same force is applied again, but the mass of the cart is doubled, the resulting acceleration is only half that which was previously measured. It's apparent that mass directly affects the cart's resistance to changes in velocity. Accordingly, mass can be defined as a measure of a body's inertia. The second property of mass is its fascinating ability to generate gravitational forces. The equal arm balance is an instrument which utilizes this property and allows for very precise mass measurements. When the gravitational attraction between the Earth and the first pan is equal to that of the second, the arm of the balance comes to rest in a horizontal position. Knowing that the gravitational masses of the two objects are equal allows us to compare an unknown mass with a standard mass based on the kilogram. It's important to realize that mass is a constant property and not dependent on an object's location in the universe. An equal arm balance would indicate the same value for an object's mass whether the measurement was made on Earth or on the Moon. In contrast to mass, which is an intrinsic property of an object, weight is simply the force with which gravity pulls on that object. A force device, such as a spring scale, is commonly used to measure weight. The scale indicates the amount of gravitational force exerted by the Earth on the cylinder. An object's weight is not a constant property due to the fact that gravitational forces vary from place to place. By mounting the spring scale and cylinder inside an enclosed container, an interesting behavior can be observed when the entire system is placed in a state of free fall. If we observe the scale while the free fall is taking place, the weight of the cylinder is seen to go to zero. Because the container and everything in it are falling at the same rate, the cylinder is unable to exert a force on the scale, and a weightless environment appears to exist. Astronauts aboard an orbiting spacecraft are in a continuous state of free fall and experience weightlessness for this very reason. It is important to recognize that objects in free fall still have weight. It is only from the reference frame of the falling system that gravity seems to disappear.